In section 14.1, 14.2, we'll be learning about inscribed angles. And what an inscribed angle is two chords of a circle with a vertex point that is on the edge of the circle. The important thing here is that the size of the inscribed angle, ABC, is 1/2 the size of the intercepted arc. AC is the intercepted arc. This is different than the central angle. The central angle is made up of two radii, and the vertex point's at the center of the circle. Now in that case, the size of the central angle is exactly equal to the intercepted arc AC. So in this picture up here, we have an inscribed angle ABC. It is 90 degrees, which means that the intercepted arc AC is equal to 180 degrees. So it's really good to know that if you have an inscribed angle that hits either side of a diameter, then that inscribed angle is automatically 90 degrees if it hits both sides of a diameter. In the second picture, we have two inscribed angles, ACB and ADB. And notice that they hit the same intercepted arc of AB. Both of these angles have an intercepted arc of AB. That means both of these angles are the same size. Okay, and how big would ACB equal to? Well, it would be 1/2 the intercepted arc. So the inscribed angle would be 50 degrees, and the second angle would also equal 50 degrees, so we could solve out for x. In this next picture here, we have AC that's a diameter, and we have actually three inscribed angles. All three of these are inscribed angles because all three of these angles have two chords and a vertex point on the circle. We know that this angle up here must be 90 degrees because it hits the two ends of a diameter, so we can write an algebra equation and solve for x. Remembering that all three angles of a triangle must add up to 180 degrees, and remembering that a mixed number can be turned into an improper fraction, and that we can multiply by the reciprocal to cross-cancel, and we can solve for x. In the second problem, we have two tangent lines, actually tangent rays, DA and DC, and they hit at points A and C, which are called points of tangency. And what we can do is we can draw in our two rays, and where the ray hits the point of tangency on the tangent line is a 90-degree angle. Notice that when I've drawn the two rays, and then I draw a line that goes right up the middle between the center of the circle and D, we get two triangles that are congruent to each other. They're the exact same size of a triangle. I know this because the radii are the same length, and this length of 10 is in both triangles. So I could use the Pythagorean formula to solve for the third side, and so these two side lengths that go from intersection of two tangent lines to the point of tangency, those two segments right there, are equal to each other. So in that case, when I do the Pythagorean formula out, I get x equals 8. Those lengths are the same. In this problem here, we're trying to figure out the perimeter of the triangle ABC, and we've only been given a couple little segment lengths. So 8 would be the length from here to here, 4, and 6. But we do have points of tangency right here, and we remember that from the point of tangency to where tangent lines intersect, those lengths must be the same length. So we can fill in the remaining lengths, and then we can add all of the lengths together all the way around to get the perimeter of 36. In our final problem, we have an inscribed angle, BAC. It has an intercepted arc of BC, which means that the angle is actually only equal to 40 degrees. The angle is half of the intercepted arc. We are told here with these slash marks that AB and AC are the same length. And so we want to figure out the arc of AB. How we can do this problem is to know that all the way around a circle is 360 degrees. So we'll take the 360, we'll minus out the 80 degrees of arc that we know, and that will result in 280 degrees. But since these two chords are the same length, that means that their arcs as well are the same length. Two chords the same, two arcs the same. So we can take that 280 and divide it by 2 and get our answer of 140 degrees for this one or for that one.